start.
My name is Albert Einstein. I was born on March 14, 1879, in the city of Ulm, in the kingdom of Württemberg. If you're watching this, I am dead. There's so many things I could talk about in my life, but one of my greatest discoveries is the general theory of relativity. You see, when most people think of gravity, they imagine something simple: an apple falling, planets orbiting the sun, Isaac Newton's invisible force pulling things together. And for centuries, Newton's law explained it all beautifully. But I saw things different. In 1905, I had published my special theory of relativity, a theory built on two key ideas. The laws of physics are the same for everyone moving at a constant speed. The speed of light is always the same, no matter how fast you're moving. These two led to some strange consequences, like time slows down for fast-moving objects. Lengths shrink in motion. Lengths shrink in motion. Events that seem simultaneous to one person might not be to other. And yes, energy and math are connected, as the most popular thing goes. And yes, energy and math are connected. E equals mc squared. But yet something was missing. Special relativity didn't handle acceleration or gravity. So I asked myself a new question. What is gravity? The answer began with what I called the principle of equivalence. Imagine you're in a sealed room. If you feel it pressed up to the floor, how do you know if it's gravity or the room accelerating upward? You can't. To you, they feel the same. This idea led me to a startling conclusion. Gravity is not a force. It's a curving. Gravity is not a force. It's the curving of space-time. Maths bends space and time like this. Planets, stars, even light follow paths along the curvature. You don't fall because you're pulled. You fall because you're moving through curved space. To describe this ain't powerful mathematics. In 1915, I presented the Einstein field equations. They may look intimidating, but here's what they mean. In simpler terms, space-time tells matter how to move. Matter tells space-time how to curve. These equations are hard to solve, very hard. But just a year later, Carl Schwarzschild found an exact solution, described the space around a spherical mass, and led to the idea of black holes. That's right, black holes came from this theory. Then came the moment everything changed. In 1990, during a solar eclipse, Arthur Eddington measured how starlight bent around the sun, just as my theory predicted. Overnight, I became famous, a scientist on front pages. Not because I sought fame, but because the universe had spoken and agreed. Today, we see my theory at work everywhere. GPS satellites correct for time dilation, light bends around galaxies, and the universe expands. A prediction confirmed by Edwin Hubble in 1920s. In fact, the field equations century, scientists test, explore, and build upon even in fact, the field equations became the foundation of modern cosmology. Even now, in the 21st century, scientists test, explore, and build upon general relativity. I once said, the most incomprehensible thing about the universe is that it is comprehensible. With with general, with general relativity, we took a step closer to understanding it, all because I dared to ask, what if gravity is not a force, but the geometry of space itself? Dobra, i jak? Źle, dobrze?
Pierwsze to jest bardzo nudne.
Co jest?
Pierwsze to jest bardzo nudne.
No jasne, że jest bardzo nudne.
Nie, wcześniej nie było aż tak nudne. Po drugich, za dużo wolności, przez to trochę traci się sens.
Adam,
Po
pamiętasz, że to ma być na
chciałem
pół godziny.
powiedzieć równanie.
Powiedziałem. E i equals mc squared.